Hi, everyone. In addition to simple random sampling, what other forms of sampling might be reasonable to reduce bias? Well, we could try systematic sampling. In systematic sampling, the elements of the population are ordered, and after some point, every kth element is selected, where k could be, for example, 2, 3, 4, 5, and so forth. So for example, we can select every third person that enters a particular bookstore on a particular day. Here, k equals 3. Now, technically, in a systematic sample, a random number generator should randomly select where we start, number 1, number 2, or number 3. Here, let's say that we start with number 3. So we interview the third person who enters the bookstore. We skip the next 2 people, and then we interview the 6th person. We skip the next 2 people, and then we interview the 9th person, and so forth. That's an example of a systematic sample. Remember, one goal is to reduce bias. Let's say that you wanted to interview about 10 students. Bear in mind, we might not be able to predict how many students will walk into the bookstore that day, but let's say we wanted to interview about 10 students. And these were back in the days when students could just walk into bookstores. Would it be wise to just grab the first 10 students who walk into the bookstore early in the morning? Well, that's probably biased towards early morning students, the early risers, and they could have their own characteristics. So a systematic sample might help defeat that kind of bias. Here's an example with the president's ages. Let's say that we select every 9th president to form a systematic sample. K equals 9. Here they form a nice row. Numbers 9, 18, 27, 36, and 45. A systematic sample. Here the ages, the observations would be 68, 46, 51, 55, and 70 years old. Trump was 70 when he became president. In addition to systematic sampling, there's cluster sampling. In cluster sampling, the members of the population are organized into groups. Here in the president's example, we're grouping them by 9s in order. The first 9 for the first cluster, the second 9 for the second cluster, and so forth. Okay. These groups are called clusters, and each member is assigned to exactly one cluster. So basically, the 45 presidents here are divvied up among the 5 clusters. Again, we're counting Cleveland twice. And then the clusters themselves are randomly selected in their entirety. And all the members of these selected clusters form our sample. So for example, here we've organized the 45 presidents into 5 clusters of 9 each. We could randomly select 2 of the clusters. So a random number generator can randomly pick 2 numbers between 1 and 5 without replacement. You cannot pick the same number twice. Let's say the random number generator gives us 3 and 5. So that means we grab all of cluster 3 and all of cluster 5. So we grab the 9 presidents here, including Cleveland twice, and the 9 presidents here, and we have a sample size of 18. So a cluster sample is sort of like if you go to a barbecue and you grab a couple of big slabs of meat, or for you vegans, maybe a couple of cucumbers. So cluster sampling is like going to a barbecue and grabbing big slabs of meat. Stratified sampling is more like going to a buffet. A little bit here, a little bit there. In stratified sampling, the members of the population are organized into groups called strata. And each member is assigned to exactly one stratum. So far, it sounds like cluster sampling. And in fact, here, the strata here, the plural is strata. The strata here are the same as the clusters from the previous example. Now, bear in mind, in practice, the nature of the grouping in stratified sampling is supposed to be more meaningful than in cluster sampling. For example, in a stratified political poll, like do you approve of President Trump, the population of voters may be divided into strata, maybe based on income level. Now, here, instead of clusters, they're called strata. And what's another difference with stratified sampling? Within each stratum, the members are randomly selected. And the selected members from the various strata form our sample. So again, instead of cluster sampling, which is like grabbing big slabs of meat at the barbecue or cucumbers at the vegan party, in a stratified sample, you pick maybe two from here, two from here, two from here, two from here, and two from here. It's a buffet. A couple here, a couple there, a couple there, a couple there, a couple there. So here we've organized the 45 presidents into 5 strata. Within each strata, we randomly select 2 presidents, and then the 10 selected presidents from the 5 strata would form our sample. Now, there is some logic to the strata. Remember that there should be some meaning. The chronological grouping could be justified by the fact that medicine has generally advanced over the years, and perhaps it's the case that that the later presidents maybe have lived longer, and maybe they can become president at more advanced ages. Maybe. It is true that some of the older presidents, like Reagan and Trump, they were in the last stratum. Okay, so let's look at some examples. Let's see if you can tell the difference. Identifying sampling methods. For each scenario below, determine whether the sampling method used is closest to simple random sampling, systematic sampling, cluster sampling, or stratified sampling. Let's go one by one. A teacher walks around a classroom and selects every 4th student to go up to the board. B, a teacher has 30 students in a classroom. The teacher holds a bag with 30 poker chips. The chips are similar, except that 5 of them are green and 25 of them are brown. Each student randomly selects a chip from the bag without replacement. Chips are not returned into the bag. The 5 students with the green chips will go up to the board. C, a classroom consists of 6 rows of students. 2 of these rows are randomly selected, and the students in these rows go up to the board. D, a classroom consists of 6 rows of students. 2 students from each row are randomly selected. All 12 students go up to the board. And E, a high school classroom consists of 4 class levels: freshmen, sophomores, juniors, and seniors. 3 students from each class level are randomly selected. All 12 selected students go up to the board. I'll give you a minute to think about this. All right. A teacher walks around a classroom and selects every 4th student to go up to the board. That's an example of systematic sampling. I'll shrink this and move this up. All right. B, a teacher has 30 students in a classroom. The teacher holds a bag with 30 poker chips. The chips are similar, except that 5 of them are green and 25 of them are brown. Whoops. Each student randomly selects a chip from the bag without replacement. The 5 students with the green chips will go up to the board. I showed you that's simple random sampling. I'm not doing good with cover up here. C, a classroom consists of 6 rows of students. 2 of these rows are randomly selected, and the students in these rows go up to the board. That's cluster sampling. D, a student consists of 6 rows of students. 2 students from each row are randomly selected. All 12 selected students go up to the board. That's a buffet, a little bit of each. Stratified sampling. E, a high school classroom consists of 4 class levels: freshmen, sophomores, juniors, and seniors. 3 students from each class level are randomly selected. All 12 selected students go up to the board. Again, this is stratified sampling where actually the strata are more meaningful. So it's a better example. Each class level of students is a stratum. This may be a better example of stratified sampling because the division of students by class level may be more meaningful here. All right, next up, we have our sample. What are appropriate and inappropriate questions to ask them? Next time.